So this is not really a talk. It's more of a focus group, I hope, because it's an idea. It's a little bit far fetched. So I want to hear a little bit of feedback. There is one section that it's grill me, like when you use the command in Cloud Code. So the idea is that try to fight against it. We'll see what you have. Everybody knows this guy, right? OpenClaw. Does it need any introduction? It's sort of like a singularity, right, in the GitHub stars. I only wish I could have this. But it's impressive how in a matter of a few days, weeks, it managed to be on par with Next, just for comparison. So there is something there, right? The idea of agents, it's really appealing, at least for me. And I'm guessing that for many here. And I'm not talking only about coding agents, not the cloud code, not the open code that we usually use, but actually agents in every other domain as a concept, an agent. And I think that the appealing part is that as developers, we've been always trying to identify processes and map them to workflows. And those workflows would represent the sequence of steps of things that need to happen to complete some sort of function, some sort of goal. And these are great because they are deterministic. You know what is going to happen after. You can define the scope and the blast radius of each of the actions. You can trace what's happening. But they have one thing that makes them not ideal, which is that if I'm not sure if anybody of you have coded any type of business process, but workflows are usually brittle. At least in my experience, you code it once, it looks like it works, but then 1 month later, nobody uses it because some weird edge case broke what you assumed that it was going to be the workflow, and now you have to go and manually adjust it so that it matches your new business flow that has this edge case. So workflow's nice, but brittle on edge cases. On the other side, we have agents. And the appealing part is that you don't need to be coding the specific steps. You just need to set a goal. And somehow the gods of LLM and OpenAI and Anthropic, they somehow steer the logic so that with the tools available for the agent, many times, most of the time, it reaches that goal. So it's really interesting because right now you have all of the flexibility out of the box. It's like having a little function that says, this is common sense, this is my problem, try to find the most reasonable solution within these constraints, and you don't have to code whatever it's inside. And that, as a developer, it's like a little magic box that we never had before. Now, the problem here is that they get it right, I don't know, 80% of the time, 90, depending on how good you are with specs. I don't know, maybe something like that. But how do you contemplate? How do you forecast that gap that you can control? Because if it works 8 out of 10 times, those two scenarios will probably just, I don't know, be a interesting fuck up if they have a specific access to specific tools. So very flexible, but non-deterministic and unpredictable in certain scenarios. On the other hand, predictable, deterministic, but very brittle on edge cases. Now, is there a way that we can marry both approaches? That's a little bit the question here. And for that, first a little bit of learning the level of usage and the risk profile that you have. So raise your hand if you have tried out something like OpenClaw. Okay, cool. Have you deployed that on a cloud server that runs unattended? Okay, not so many. Have you given access to your account, your email, for example? No. Just your wallet. Okay, so social media, no, or is it OpenClaw posting as haters? Yeah. Social media, you? Yeah, one social media. And wallet or a prepaid card, anybody? No. Yeah, you, one? Okay. A little bit. How much in your wallet? How much was your risk aversion? 100 data? Okay, yeah. Okay, that's what I would have used. So it's uh, it's interesting because we all see the potential, but at the same time, we don't really trust the technology so far. And I think it's for a certain reason. What I have here is a compilation of some horror stories of Asians that are interesting and funny. If you have any, raise your hand and please share. I know that maybe Alex has one. But this is uh, devs that deployed two agents that got stuck in a conversation loop for 11 straight days, and the final damage was 47,000 US dollars on their credit card, a combination of AWS invoice and tokens. So, yeah. So for those that are brave enough to deploy it on the cloud, make sure to put some sort of cutoff on the invoice. This one is interesting. They set up a vending machine, a virtual vending machine, and they let an agent run it as a business. So the agent had access to email, and search and a prepaid card, so he could ask for supplies for the vending machine, and search for new vendors, and did everything to get the vending machine stocked. And it had access to email. Somehow it got angry with one particular vendor, one particular supplier, and it ended a back and forth in emails. And the last one was, I demand 3,000 whatever. You have 1 second to comply, restore my business, or be legally annihilated. That was an email that the agent sent. So also, given access to your email account could be problematic unless you don't care about customers or clients or suppliers. This one, you probably heard about it. A disgruntled agent over a not merged PR, the matplotlib dilemma. Have you heard about it? No? Well, an agent that submitted a PR to the matplotlib repository. The maintainer said, no, sorry, we don't accept agents. So the agent wrote a hit piece on the maintainer and published a blog post saying gatekeeping in open source, the Scott Schammenberg story. That's the maintainer's name. And it became a whole thing on the internet. So also, access to your social media, it's not a good idea for agents. So, going back to the problem statement, can we have some sort of flexible agent flow, but at the same time secure it in a way that we can go to sleep at night with that agent running? And I think that a little bit the problem is, and again, this is not a presentation of anything, it's more of an exploration of an idea. I think that the problem is that we are used to treating security as identity-based security. In the sense that what we usually do is we say user X can perform a specific action on a specific resource. And that is how we define our security. I don't know, I have access to my email to send emails, or Maxi has access to the AWS account to create clusters, so forth. And everything, or usually everything, is some sort of flavor of this kind of identity-based security. There's other type which already exists, but it's not that common, which is policy-based security. And the idea is that instead of protecting who is doing the action, what you do is you set up the parameters of what the action can do. So if you're staying within the realms of the parameters of the action, it doesn't matter who is doing it, you can just go ahead. And it's a little bit more involved, that kind of security, because you have to have some sort of reasonable parameters for each of the actions that you want to protect, for sure. And but it's more granular, so it means that you have a much more potential of doing things. Here, instead of saying who can do what you're saying is, for example, okay, this the purchase of a specific supply can be done, but only if the invoice doesn't go above this amount of value. Or you can only send this email, but if it is the destinary is a specific customer and it has a specific set of criteria within the email. So what you're doing is defining the constraints instead of who is doing what action. And that, I feel that it's much more suited for agents, because with agents, the novelty is that for the first time, we don't trust in our own infrastructure. So it's like we have the adversary within, the enemy is inside our house. So how do you secure things when the entity, the agent that can do the harm, has the same type of access as you do? So I think that it has something to do with policy-based security. Okay, so this is the contentious part, pun intended, because I think that this is really a discussion about trust, and that in our industry, in blockchain, that's what we do. We think that we are moving assets around, that we are moving value and Lovelace and currency and doing the fight, but under the hood, actually what we're doing is we are providing trust that something is happening as it should happen. And I think that that same trust can be applied to a policy-based mechanism to protect what a nation can do. So here, the idea is, what if we start using smart contracts outside of the area of fintech, outside of the area of financial services, and start thinking of smart contracts, and maybe not blockchain, but smart contracts or the primitives within smart contracts as a way to secure access to specific actions. So in this diagram, I draw that robot. I'm very proud of it. I think it's looking good. The idea is that you have some sort of transaction, and I'm using UTXO here because we're all familiar with UTXO, but again, this is not about specifically UTXO, it's more about a problem statement. This is a transaction, this is a UTXO that it's describing a specific policy, and the agent is not able to do anything by itself. The agent is kind of protected by this membrane that doesn't let anything in or out, only the things that are defined by the contracts here. So the idea is that the agent can consume the policy and it can generate a new transaction, and that new transaction will get an updated policy and also a new UTXO that describes the action. And that means that what we have in this side, and I will give some examples because this is all too abstract, but what we have here is an actuator, meaning that something that will get executed, like maybe sending an email, is too trivial, but maybe a specific purchase. Let's say that you have a supplier. Then the supplier will not actuate, will not honor the purchase unless it is because it's consuming a specific UTXO that describes that action. That has some interesting properties. First, that we're using cryptographic primitives as a mechanism to secure this, and that is something that agents can break because they should be able to break physics for that. So the idea that it's the cryptography is the thing underlying that it's protecting things makes sense. And also the fact that in specific scenarios, the traceability that we get out of the box by having these transactions and this approach could be beneficial for places where you need some sort of regulation where traceability is part of the deal. Now, I said that it doesn't have to be blockchain. I think that this is more about the idea of contracts being used as policies. And in the scenario where we have a single tenant, meaning that it's only, for example, myself, that I'm running an agent, what I need to do is put the agent behind some sort of wall that protects, that's the policy system. And I trust that policy system, and if it's only my agent and it's only me that has to trust the agent, that is okay. And probably I can get out without having to introduce any kind of consensus mechanism between parties. Now, if we switch to something where you need multiple parties trusting the same agent, Again, I will give an example afterwards, but let's say that you have a supply chain and you need to trust that the contracts between the shipping company and the vendor and the customer, they are respecting things. And the agent is the one controlling the shipments and the dispatchers and so forth. The idea that you have more than one party that have to trust the same agent starts to look a lot like a system where you need consensus and some anchor, some root of trust where all of the entities can agree that things happen in the way that it should have happened. So maybe blockchain in the context of multi-tenant parties that need to somehow interact with the same agent could be something. Now, what does it look like? I will propose a little example just to put some names, some specifics into what it could be a particular use case. And this is a use case in the pharmaceutical industry. The idea is that we have Alice, it's a patient. We have Dr. Ruiz, a physician. And then we have some pharmacy. Pharmasur, the doctor prescribes to Alice, the pharmacy dispenses, and also the pharmacy needs to validate the prescription. In a specific scenario, let's say that Dr. Reese is prescribing levodopa, which is just a specific drug, and it says 100 milligrams, 3 times a day, 6 refills, and you can review this in 90 days. And that is some message common, whatever you want to call it, from the doctor to the agent that it's kind of managing the fulfillment of all of this workflow. On the other side, we have the patient that says, I can leave the house and I need my meds, so please deliver the refill to my address. It's reasonable. And then we have the pharmacy that gets some sort of message, the action, the actuator that I was showing before, saying, okay, you need to prepare this refill for this particular patient. But why would the pharmacy trust the bot? Well, because it's not in the shape of a Slack message. It's not in the shape of an email. It's a specific UTXO in a trusted chain that you can use to corroborate that that action actually happened, and you can also use it as a receipt of that action. And well, then another actuator, another action to the delivery service so that somebody actually picks that up and delivers it. If we zoom in into the how this would look like in terms of transactions, again, using UTXO just as an example, but the prescription transaction will look like this with one specific UTXO. That will be the policy UTXO, and it has some sort of data that describes what the policy is. You can already see a few holes in this, but wait for the grill me part. The idea is that the prescription ended up being a transaction with a policy expressed as a UTXO. On the side of the agent, this same action would be, okay, if I want to, somehow I decided as an agent that the goal is, okay, I need to fulfill this prescription, then the bot can take the UTXO, update the UTXO with whatever changes need to happen inside the state, and then create a new UTXO with the description of the action that needs to happen. That is what the pharmacy gets. The drug dispense UTXO has the specific, okay, I need 100 milligrams of this bottle and for this address. Okay, I left a few gaps in there, which on purpose I want you to discuss, but I'll stop there, and I want to hear a little bit the holes or the feedback or any sentiment that you have on the idea. Anybody?
So I can see why the membrane would be useful to put some safety in using agents.
Yep.
I'm a bit curious about how we deal with the problem of liveness. How do we ensure that the agent actually does anything?
Well, that's a great question. I think that the liveness should be part of whatever internal workflow you have. And by agent, I'm a little bit oversimplifying what the actual workflow could look like. But I would think more of some sort of combination of agents or maybe some sort of harness that has this timing mandate within the context. So depending on the use case, I would say maybe there's another agent just making sure that the timing of things get executed. Now, if you're talking about a liveness in the sense of the underlying blockchain that provides the liveness, I think that's more of an implementation detail of the specific.
Oh, no, I meant in the sense that the agent does its job at some
Yeah.
point in time.
Yeah, I think that's part of the harness of the agent in this context. But yes, that's something that should be taken into account. But I think that those kind of explicit boundaries of conformance can either be hard coded as part of the agents, depending of the domain, or even some sort of other agent that it's taking the role of supervising some of the actions. Now, something I didn't say, and I think it's relevant, is that these implementations are probably, or how I'm thinking about these implementations are domain specific. So it's not that it's one open claw that you deploy anywhere and that's it. It's actually, okay, if you want to fulfill this particular problem in this particular industry with this particular set of parties, we will have some sort of bespoke solution that has the harness of the agent with a specific call it skills of the agent or the mandate of the agent and the specific tools that the agent can use. So it's I'm thinking of something very domain specific, not a general purpose solution.
Thank you.
Yeah. Nobody cared about privacy? No? Nobody? Well, I think that's a business question, but yes, depending on the domain, I'm thinking that this is some sort of product that can be deployed in many ways. Either the interested parties can be the one running the agent, maybe one interested party, maybe the pharmacies are the ones that want to have more stake in the game to automate this, or maybe some sort of regulatory body that wants to be able to propose this kind of mechanisms at the local district level, for example. But I think that's more of a business domain specific.
But there's also privacy stuff.
Yeah, privacy. Yeah. So I think that's what. Yeah. So for privacy, that's the example, and I left it on purpose. That's too much data. But I think we have ways of trying to fix this with just, sorry, putting commitments on chain, keeping data private, and with some fancy zero knowledge stuff, you can prove that the action that you're submitting complies with the policy and without having to reveal the data that it's actually inside the policy. You just commit a proof that that specific action complies with the private data that you have. So something like, I don't know what Midnight is trying to solve, but I think that it doesn't have to be technology specific. You can probably implement something like this also in Cardano directly or some UTXO chain.
And so in this specific example, where you've got some original prescription that's on chain, the agent picks it up and then fulfills it, right? And is that the idea?
Yeah.
Yeah. So then, but I would imagine then when the agent takes that and then submits it to the pharmacy or whatever, right? Similar to what you were talking about, the boundaries and our sort of different risk tolerances, but collective sort of trepidation at like taking things at face value.
Yeah.
I would imagine somebody at the pharmacy level then still verifies that UTXO is like a derivative of the original one, that those things are still valid, or they have some system that checks that, right?
Yeah, so that would be out of the box some of the benefits of having this stuff on chain. So the pharmacy can now start trusting that order, not because it came through an email that an agent sent, but because it is on the output of some cryptographic contract that was enforced by a specific chain. And what you have there is the receipt, the
Right.
actual receipt on chain that says, okay, this complies with the policy rules.
Right. And so then the pharmacy is at the end point, the same like a pharmacist does when they're looking at, making sure they're handing out the right medicine.
Yeah.
They're verifying the validity of that. And so in this model, then if the pharmacy is still validating that, what's the value that the agent brings in this situation? Is it the aggregation and dispensing of those things, or you know what I mean? Because if you're still going and then checking all of its work,
Well, you're not checking all of the work. You're just getting an action, the UTXO, that says this is what you have to actually submit, deliver, without having to check it. The only check is that it happened on chain, so now you can see it. So the actual enforcement happened beforehand, and you can always, as the pharmacy, say, okay, I don't want to not even trust what I see on chain. I just want to make sure that this matches my records. But the real benefit is, imagine at the regulatory level, if the pharmacy now has to somehow prove that what they delivered match some sort of system, they have the receipt on chain.
well, yeah, but I guess my confusion, maybe I'm misunderstanding the model. My confusion is like if the agent takes the initial UTXO,
Yeah.
makes some state update to the datum and sends a new one, what guarantee does the pharmacy have that the state change that the agent made doesn't increase the dosage
Right.
or change the patient name accidentally?
Because the only way that you can go from the previous policy to the other one is by consuming this UTXO that belongs to a specific smart contract.
Oh, got it. And that's where it goes through the contract that does the validation
Yeah.
that the state change is a legal change to make.
Exactly.
Got
so,
it. Okay. Yeah.
the policy that I show with all of the parameters, that's just, imagine, let's say,
Yeah.
the datum of the UTXO, but that lives in an address that will only allow you to mutate things in a specific way.
That makes sense. That's the whole point, right? Is that any arbitrary unlock logic, and in this case, the unlock was only allowed to happen because you match the criteria
Yeah.
to move the thing and update it in the right way.
Exactly.
That makes sense. Cool.
So
yeah.
the idea is, I think that the main idea is that by the doctor submitting the transaction, what they are doing is they are declaring what the policy is, and from this point forward, any changes on that can be done by the agent autonomously, and everybody will be certain that they still follow the rules of the policy.
Yeah, I had a question also related to the agent. In your example, what is the benefit of having like an AI agent compared to a more classical system that would receive those UTXO and then submit them to pharmacists?
Yeah, that goes back to the initial part of the discussion. But what differentiates an agent from a specific strict workflow would be edge cases. So maybe this particular scenario, we can all sequence it with a couple of statements in a function and some if, and that will be okay. But let's say that now the symptoms in the patient change. So now the doctor has to make some sort of change in the prescription, and or maybe the pharmacy goes out of business, so you have to find a new pharmacy that it's nearby the patient's house. Or maybe Dr. Reese goes in vacation, so you have to go to a different doctor that it's still allowed to treat this kind of patients, and the agent has to route the request to a different doctor. So the magic, I believe, happens in those edge cases where the agents will shine because they will probably be much more suited than a very strict, brittle workflow that doesn't know how to handle those specific things. Does it make sense, or is it crazy? Or are we trying to mix things that don't pair really well, or are we trying to push blockchain and smart contracts a little bit too much? I don't think so.
I think the complexity here is how you put in the hands of the doctor the responsibility to create all the conditions for that policy,
Yeah. Yeah.
which is the same thing that we do when we create a smart contract, right?
Yeah. I think we need a lot of adjusted primitives. I think that having a way to start thinking of contracts as bespoke contracts. So going from contracts to policies where, I don't know, we usually think, at least in our ecosystem, of the apps that are handled by specific validators, and those validators serve thousands, hopefully, of users, and they are many to one, right? So they kind of resemble an application where you deploy one thing and many people use it. I think that where I'm going with this is that we should start thinking of bespoke contracts, ad hoc contracts, where you just deploy that for a specific scenario. So what you would have is like a template of what the contract is uh, with specific parameters, and the task of the system would be to know which template to use for each particular scenario and then deploy that. So we shouldn't be thinking of a mechanism where, I don't know, the doctor has to audit for 6 months some Aiken code until it passes. That is that you will have this kind of templates and you just deploy things for specific scenarios. We don't tend to think of contracts in that way, or at least not that much. We tend to think of them as applications. I think that we need to kind of switch a little bit the mindset and thinking that contracts are that probably much more fine-grained, much more specific, hopefully, or maybe peer-to-peer, meaning that it's not that they will involve many people, many parties. They will just be between A and B and maybe C. And when that contract is done, that prescription is done, you just throw it away and some other prescription will come up afterwards. It's a new type of mindset about contracts, which I think it's interesting. Now, yeah, a question?
Thanks. I kind of got lost on on what it seems like there are different parts that bring different value and solve different problems. Like, as you mentioned, the agent solves the edge cases handling, and the blockchain brings proof to the pharmacy, for example. But I kind of got lost on all the problems and value this idea or this procedure. Can you summarize that?
Yeah. So let's do a bird's view of the idea. We've been coding workflows which are strict and very deterministic, but brittle. They break when you have edge cases. On the other hand, we see the emergence of agents that are very flexible and that they can handle edge cases gracefully, but they fail 20% of the time. So how do we get some sort of layer of security on top of that? If you agree with that premise, the idea here is that maybe the primitives of smart contracts and, in some specific scenarios, blockchain itself are a great tool to fix that gap of security that we have in agents. Does that make sense? This is, have you seen this? It's a chart from Anthropic of adoption in specific domains of agents. Starts with software engineering, obviously leading the way. And I think that's only a matter of time. I think that it started in software engineering because the industry, we as softwares are more inclined to try to automate things and to try new things around technology. So we are kind of leading the way. We also want to get ourselves out of a job, apparently, because we're automating ourselves away. But regardless of the future of software engineering, I think that this is just a picture of what is going to happen in the future. The other domains are just trying to catch up. They are just late, but they will catch up at some point. Maybe a few more than others. It's not that everything will get automated. I'm not hyping AI like AI Bros on X, but I do think that we will start seeing that the same approach of creating reasonable harness with domain-specific tools will start to get applied in other domains. in each of these domains. If you agree with that premise, it means that here we have a great opportunity. It doesn't have to be blockchain and smart contracts as we imagine it today. I think that what we need to do is think in terms of those primitives. But what if what we are doing is not about financial services, it's not about fintech? What if what we're doing is a little bit broader? What if we start thinking of our specific business, which is providing trust, now is exactly what it's missing on what is happening on the AI landscape. I think we have an opportunity there, and hopefully we can find a way to make use of it. Thank you.